on classifying the different types of reactions. So as we go through this, I recommend pausing the video after each reaction and just kind of writing them down, and that way you can get those notes and hopefully recognize them fairly quickly. In chemistry, one of the big things we want to know is if we mix two chemicals together, what are the products going to be? And so what we need to be able to do is classify each type of reaction. So with this lesson, we're going to learn about 5 different types. And the types that we're going to learn are synthesis, decomposition, single replacement, which is also known as single displacement, double displacement, and combustion. All right, so the first type of reaction is synthesis. And what synthesis is 2 or more substances that combine to form a new compound. So the easy way to think about that as far as a simplified version of a formula as we can get is we have A plus B produces AB. This would be like baking a cake. You put all your ingredients together, and then when you do that, you're going to get one product out at the end. That would be your cake, the AB. So, go back a slide here. So you can think about another example here. We've got a hungry bird right here, and it eats a large worm. When it does that, we get this giant happy bird. So we ended up with combining these 2 things into one substance. Our birds and our worm combined to make one brand new bird. Okay, so there's our A plus B plus. And then we've got iron plus oxygen is producing iron oxide. This is rust. So anytime you see rust on like a bicycle, car, that type of thing, it's basically this reaction right here. Another one that is common is hydrogen plus oxygen. Those will combine to produce water. So taking 2 or more substances, we're combining them and forming a new compound. Next type of reaction is a decomposition reaction. In a decomposition reaction, we're taking one single object and breaking it up into smaller parts. So we're going to at least end up with 2 compounds, possibly more. So it's basically the exact opposite of what we just looked at with a synthesis. We have AB, and that's going to break down into A plus B. So you can look at this egg right here, and it's an egg with a turtle inside of it. After it hatches, I've got the egg shell plus the turtle. So I ended up with 2 products there, which start from a single. As far as a chemical reaction we go, I've got silicon tetrachloride, and that produces silicon plus 2 chlorine molecules of gas. And this would be a reaction that I'd be interested in. I'd want to know that this is going to decompose, because we do know that chlorine gas is a very toxic substance. If I inhale it, it's going to burn my lungs. If I even get it on my skin, it's going to burn my skin. Be really concerned about getting it in my eyes, because that could possibly cause you to go blind. So it's something that I would be concerned about if I was doing a chemical reaction. Next type of reaction is a single replacement, also known as single displacement. And what we're going to do here is one element and replace it with another element in a compound. So we can look at AX plus B, and what happens with this is the A and B trade places. So I'm going to end up with BX plus A. So if you look down here, this is kind of a dating scenario. We've got this guy who's all by himself, and then this couple is on a date. So during the course of the date, they end up trading places. So the guy with the red shirt ends up getting the girl, and this guy ends up by himself. So that's exactly what would happen in a single replacement reaction. So let's look at this reaction with calcium and hydrochloric acid. Calcium and hydrogen will end up trading places. So I'll get calcium chloride plus hydrogen gas. So the calcium and hydrogen ended up trading places. Next type of reaction is a double displacement reaction. This one is also got a separate name. It can also be known as double replacement. Just like you have there. And so with a double replacement reaction, basically what we're doing is we're going to be switching places with 2 elements. We're trading places. Sometimes books will say ions are switching places, but we'll be looking at this right here where we got AB plus CD. So these would be 2 separate compounds. they're going to produce AD plus CB. So what happened there was A and C traded places. So I ended up with AD and CB forming together. So you can look at the comic down here. It's like having this guy with a hat, so he would represent one compound. This guy with a different hat, and those two end up trading their hats. So when they do that, we've got two brand new compounds. So let's look at an actual chemical formula. And what you should be looking for is when you see two compounds, especially if they're ionic bonds, they should be trading places or have the ability to trade places. So what's going to happen here is we're going to get silver and sodium are going to be trading places. So I'm going to get silver chloride plus sodium nitrate. So those two form a couple new compounds. Now one thing that we're concerned about with double replacements is something called a precipitate. And this is a term that you should know. A precipitate is a solid that forms from two solutions that experience a double displacement reaction. So what we would be doing is we're going to take two of our aqueous solutions, and again, aqueous means it's a solid dissolved in water. So we're going to take these so we can actually get a reaction to occur, and we're going to mix them together. And a lot of times you'll have these clear solutions, and then when we get done, you'll get this product. So a couple examples here. This is a pretty dramatic one where you've got this clear solution, and we're mixing kind of a yellow solution in there. Now, as soon as these two compounds, or two solutions come into contact with each other, we're forming a brand new compound. So I'm getting this solid reddish colored stuff right here, and this would probably eventually sink towards the bottom. A lot of them will look kind of grayish in color, and you'll get a brand new precipitate there. So this would be sodium chloride, salt water basically, with silver chloride. Both of them would be clear solutions, but when we mix them together, we get this grayish substance. Now one thing that you'll see a lot of times, if I go back to this reaction right here, we've got silver nitrate. We call that aqueous. Sodium chloride would be aqueous. And then what we would end up with is silver chloride would form a solid, sodium nitrate would be aqueous. So what would happen is I'd mix these two together, I'd form a solid, that is my precipitate. And we like to abbreviate that PPT. And then what we end up over here is an aqueous solution of sodium nitrate. So if I wanted to, I could filter this out. I could just use a coffee filter actually. Filter this out, and then the solution that's left in the water is sodium nitrate. If I wanted to get the sodium nitrate by itself, I would just have to evaporate the water. All right, the final reaction that we're going to learn is a combustion reaction. In a combustion reaction, we're going to take some type of carbon compounds, combine it with oxygen, and then we're going to provide heat typically. And after this reaction goes through, we're going to always produce carbon dioxide and water. The other product that we get is energy, which we use that to heat our homes, power certain types of vehicles, and that type of thing. So the basic idea is, here's our carbon compounds. Okay, so this is butane plus oxygen is going to produce carbon dioxide and water. Okay, so we'll always get that right there. We don't have to necessarily always use that particular fuel. We can use some different ones as well. So no matter what it is, here's methane. This is what you would use as natural gas in your home. Plus oxygen is going to produce carbon dioxide and water. No matter what it is, that is your product. So if I gave you CH4 plus O2 and I asked you, what are your products in this type of reaction? You should be able to tell me carbon dioxide plus water. And that's because I've got my carbon compound plus oxygen produced. The next one that we've got, C2H6 plus oxygen. Again, that's going to produce carbon dioxide and water. So no matter what, you'll get this. So this is a rapid reaction that's going to occur between oxygen and some sort of fuel. So our carbon compound can be thought of as a fuel. All right, so spend some time learning these reactions. They are very valuable, and one of the big things is we always want to be able to predict the products. Eventually, following this course, that's something that you should be able to do. Thanks.